Okay, I've dipped out some of the salt water from the pressure cooker, which is over here. And there's the top of the pressure cooker. We're going to put it up in a minute. And then I put some ice in our distillation cell. And what we're going to do is to drip that water into this pot here and then measure its conductivity. And what we're going to do for measuring conductivity is use an ohmmeter. And the ohmmeter, when it reads open, is infinite, and that 1 means that it doesn't read any current, so it's infinite resistance. Now this is a cell which has 2 copper plates that are opposed to each other, and there are 2 wires that are soldered to these plates. I'm going to stick it down in the solution and measure the resistance. And the scale on the resistance is in ohms. So it measures up to 2 kilo or 9.9 kiloohms. So I'm going to put this down in the solution and measure the resistance. And this is the salt solution. So it's reading, wow. Maybe that's my flesh reading that. It reads about 900 ohms. About 900 ohms, let's say. No, it's down around 7. Well, it's the high hundreds, 800, 900. What happens is these plates get bubbles on them after enough current's drawn. So when you first stick them down in the solution is the best measurement. Okay, so it looks like it's about 500 ohms maybe. Let's see. Yeah, 600. 900 now. There's still water on them, so there's still bubbles on the water. Until that water dries off, and you stick it down in there, it gets about 570 to 600 ohms, something like that. Okay, so now what we're going to do is we're going to clean up this measuring cup. And we're going to boil off this salt water and then remeasure that. And actually I'll have somebody taste it before we measure it and see if it tastes salty. And we can have them taste the water that's in the pot, or somebody taste the water that's in the pot and show that it is salty. So here we're going to set the experiment up and then boil the water, and then the steam will go through the tube, through the coil, and drip out into the measuring cup. And we'll only do a little bit of the water, but that's all we really need. We have to submerge this conductivity probe. That's all we really have to do. So we're going to close the pot up. Now the pot is sealed, and we turn on the heat on pretty high, and it's going to take a little while to come to a boil, but we'll sit here until it does. And I'm going to turn the meter off in the meantime. And you can see the burner's pretty hot, but the pot will start making some creaking noises when it starts to get some pressure in it. And the pressure gauge on the top, this is a relief valve, and so of course those of you who've seen pressure cookers know that the relief valve comes up and it hisses when the pressure becomes too great. So this thing can't achieve any more than about 1 atmosphere of gauge pressure, which means that the pressure in the pot is 1 atmosphere more than the outside pressure of the air. And so that keeps the pot from being in a position to explode, because it develops quite a bit of force on the lid. You don't want the thing to blow up. So we'll wait on it. And I may just check the outside of it occasionally with this temperature probe. So pot isn't really hot yet. Yeah, wow, this is though. Well, it doesn't even read very high. Well, I think I'm going to get the laser probe, and we'll check it with that because it's a more accurate reading in this case. So now, if I measure the pot with this laser probe, it's actually a bolometer. It doesn't make any measurements with the laser. It's reading 102 degrees on the outside, so it's got a long way to go to boil. Camera. Okay, so yeah, I guess it's coming up a little bit. We're just gonna have to wait on it.